Hello, today we're going to look at an application of using inverses to solve a system of equations. Now there's a lot of ways to solve a system of equations. We've looked at a few of them. We've looked at just using the equations as is, like we see here, and just using row elimination to get rid of x and y. We have seen putting it in matrix form and then using row elimination. And then this one is multiplying by the inverse matrix to give you the answer. So it says if A is an invertible matrix, then the system of linear equations represented by AX equals B has a unique solution given by X equals A inverse B. So we have to unpack this a little, because what is meant by AX equals B? So that's a matrix equation. Matrix A times matrix X equals matrix B. It is saying I can represent a system of equations like I have here as the product of two matrices. Okay, so what does that look like? You're going to take, in matrix A is the matrix of all the coefficients. So 2, 3, 1, 3, 3, 1, and 2, 4, 1. Matrix X is the matrix of all the variables. And you put that in a column matrix. So that one goes X, Y, Z. And then matrix B is the solution matrix, so it equals the solutions here, -1, 1, -2. And that's more, maybe I should say, the answer matrix, so what each of those equations equal. So I can rewrite our system like that. And does that make sense? Well, let's think real quick about this. If I multiply these two matrices, can I? Well, it's a 3 by 3 times a 3 by 1. And what would that create? Well, those are the same, so I can multiply. It would create a 3 by 1 matrix, which is what our equation says. And then if I do actually multiply these, notice how it creates, we're saying it creates a 3 by 1 matrix. What is in the first slot here? I would take first row times first column. So I'd have 2 times x plus 3 times y plus 1 times z. The next one, I would have second row times first column. And that would be 3x plus 3y plus 1z. And then lastly, I'd have third row times first column. And that would give me 2x plus 4y plus 1z, which, take a look, that is the same as the system matrix over there. And we are claiming it equals this, or it equals this portion of it. So we see that if we set up our system as a product of two matrices like this, it can sort of make sense. And this gives us the matrix equation A times X equals B. What are we trying to figure out? We're trying to find out X, the value of those variables. So I need to get X alone. So I have the equation AX equals B. How do I get rid of matrix A? I have to undo that, but there's no division with matrix multiplication. So instead, I have to use the inverse. So I take the inverse of both sides, and A inverse times A is the identity matrix, like we talked about. So that gives IX equals A inverse B. But anything times the identity matrix is just itself, so nothing changes, giving me X equals A inverse B. So if I can figure out what the inverse matrix is, I will just multiply it by the B matrix, that solution matrix. And that would give me the value of the coefficients, the value of the variables that I want. Now notice a very important thing. I multiplied B on the left side, because remember, matrix multiplication is not commutative. So over here, I have to multiply A by A inverse. And they have to be next to each other. That right here is different from that right there. Okay, there I'm multiplying X by A inverse. But I need to multiply A by A inverse, so I need to put it on the left side. Not over there, but on the left side. So with matrix multiplication, you talk about multiplying on the left or right. Left-hand multiplication, right-hand multiplication. And I need my inverse to be next to the A. So I multiply on the left, as I did here. But if I do it on the left on one side, I have to do it on the left on the other side. So it has to be A inverse times B. The order is very important. And that's because we saw matrix multiplication is not commutative. Okay, so this means I need to figure out A inverse. I need to figure out what the inverse matrix is. So here we go. We're going to practice finding a 3 by 3 inverse. So I have 2, 3, 1, 3, 3, 1, 2, 4, 1. I'm going to attach the identity matrix. And then we use row elimination to get rid of the values we need. So first of all, I'll use row 1 to eliminate this 3 right here. So I'm going to have to go -3 times row 1 plus 2 times row 2. So in green, I'll write this new row. So I get -6, -9, -3, -3, 0, 0. And then my new temporary row 2, I can write this in light blue, is going to be 6, 6, 2, 0, 2, 0. And I'm going to add that green and blue. Okay, so I'm saying the first row is going to stay the same, but I'm going to get a new second row. So -6 plus 6 is 0, -9 plus 6 is -3, and then I get -1, -3, 2, 0. Okay, now I need to go through, and I need to get a new row 3. So to get my new row 3, I'm going to have to go -1 times row 1 plus row 3. Because going back to my original row 1, I have to multiply that by -1 in order to add with the 2 down here to eliminate. So I get -3, -1, -1, 0, 0. Okay, so let's add row 1 and row 3. I get 0, 1, 0, -1, 0, 1. Now I'm going to use the second row to eliminate this 1 right here out of my third row. And so in order to do that, going right here, we're going to go row 2 plus 3 times row 3. And that's going to give me, so we're keeping the first row the same. We're keeping the second row the same for right now. -3, 2, 0. And now we're going to change the third row. So we multiplied this temporarily by 3. So now we're going to add row 2 and row 3. So we're going to add these two, that green and the blue. 0 plus 0 is 0. -3 plus 3 is 0. -1 plus 0 is -1. And then I have -3 plus -3 giving me -6. 2 plus 0 is 2. And 0 plus 3 is 3. All right, now we're going to work up, and we're going to get zeros here, and then a 0 here. But what I'm going to do first is I'm going to multiply this row 3 by -1, so I can get a positive 1 there. So that's just going to change a couple things here. This will become +1. This will become +6, and then -2, -3. Okay, now what do? We're going to take row 3, and we're going to add it to row 2. That will create a 0 right there. Okay, so this time in matrix, we're keeping the third row the same. We're getting a new second row. So it's 0. 0 plus -3 is -3. 1 plus -1 is 0. 6 plus -3 is 3. -2 plus 2 is 0. And -3 plus 0 is -3. Okay, next, we're going to use the third row to get a 0 up here. So we're going to go -1 times row 3, add it to row 1. Okay, so let me draw our new row 3. It's going to be 0, 0, -1, our temporary row 3. -6, 2, 3. So we're going to add that light blue, the dark blue up top. To get 0 plus 2 is 2, 0 plus 3, and then -1 plus 1 is 0. 6 plus 1 is 7. Oh, sorry, -6 plus 1 is -5. 2 plus 0 is 2. And 3 plus 0 is 3. All right, we're almost there, guys. Almost there. So I'm going to bring my matrix up here. And I'm just going to copy this again. 2, 3, 0. -5, 2, 3. However, on the second row, I'm going to multiply that all by 1/3, negative 1/3, which is the same as dividing by negative 3. So that gives me 0, 1, 0, and then negative 1, 0, 1. So that gives me a 1 in that slot, which is what I want. 6, negative 2, negative 3. Okay, we're almost there. Now, I need to use this to eliminate that. So we're actually temporarily going to multiply row 2 by negative 3 again, and then add it to row 1. So I get 0, negative 3, 0, 3, 0, negative 3. And let's add it together. Okay, so again, copying that third row can be real lengthy to find these inverse matrices. We're going to keep the second row the same. All right, let's add the green and the blue. 0 plus 2 is 2. Negative 3 plus 3 is 0. 0. 3 plus negative 5 is negative 2. 0 plus 2 is 2. And negative 3 plus 3, 0. Okay, one last step. I need that first row to be a 1. So we divide everything by 2 and I get 1, 0, 0. Negative 1, 1, 0. Hey, look at that. We got the identity matrix on the left side, which that means we have found the inverse on the right side. But we're not done yet. Okay, so I'm going to slide over. Our inverse matrix then, A inverse, is equal to negative 1, 1, 0, negative 1, 0, 1, and then 6, negative 2, negative 3. Okay, and we said A inverse times B equals X. Okay, or as it was written, X equals A inverse times B. So we need to take our inverse matrix and multiply it by the B matrix, which was what all the equations equaled. And we will multiply that by our answer matrix, which you can see off to the left of the screen, negative 1, 1, negative 2. And that is a 3 by 1 matrix. So if we multiply these together, it's going to give a 3 by 1 matrix. Okay, a 3 by 1. All right, so let's do that. First row times first column gives me 1 plus 1 plus 0. And then second row times first column gives me 1 plus 0 minus 2. And lastly, that third row times first column gives negative 6 minus 2 and then plus 6. So our simplified result is 2, negative 1, and negative 2. And there's the answer. So x equals 2, y equals negative 1, and z equals negative 2. And you can take all those, and if you want, you can plug them in to the system over here, and the left will equal the right. So a summary of that, we had to find the inverse of the coefficient matrix, which was a lengthy process, and then multiply it by the B solution matrix, which was what each equation equaled, and then that gave the answer.